Now this is to find the nth Fibonacci number. Now let us recall what are the Fibonacci numbers. In Fibonacci numbers, two values are fixed, 0 and 1. You add the two values, 0 and 1 is 1, you keep it down here. Then add the last two values, 1 and 1 is 2, keep it over here. Then again add last two values, 1 and 2 is 3, write it over here. Again add last two values, 2 plus 3 is 5, write it over here. Last two values, 3 plus 5 is 8. Then add 5 and 8, it's 13. Okay. Now these are the Fibonacci numbers. But what is the nth Fibonacci number? If I ask that I want the fourth Fibonacci number, the fourth Fibonacci number is 2. This is the first Fibonacci number, 0. This one is second Fibonacci number. This one is your third Fibonacci number. If I ask for eighth Fibonacci number, it is 13. See, this 8 is the seventh Fibonacci number. Got it? The logic of this program is here. See, now suppose I want the fifth Fibonacci number. The fifth Fibonacci number is 3. Let's see how. We'll start from the main function. Enter the nth value whose Fibonacci number is required. I enter 5. 5 will be assigned to the variable n. Is 5 greater than 0? Yes. The fifth Fibonacci number is, you are invoking the nth Fibonacci function, taking the value 5. 5 will be assigned to the parameter n. Is n equal to 1? No. Is n equal to 2? No. Now, here you come. You are doing the recursive function call. You are invoking the nth Fibonacci function with the parameter value 5 minus 1, that is 4. So nth Fibonacci function will be called with the value 4. But what about this? Nth Fibonacci 5 minus 2 is 3. This nth Fibonacci 3 function call is never called. So compiler will push it into the stack. See, nth Fibonacci will be pushed into the stack. That means this function will be called later when all the recursive calls are over. So this nth Fibonacci 4 is called, right? Through this, 4 will be assigned to the parameter n. Is 4 equal to 1? No. Is 4 equal to 2? No. Now nth Fibonacci 4 minus 1 is 3. So nth Fibonacci 3 will be called. But nth Fibonacci 4 minus 2, nth Fibonacci 2 is not yet called. So compiler will push nth Fibonacci 2 also on the stack, that it has to be called later. And the nth Fibonacci 3 is invoked. This 3 will be assigned to the parameter n. Is n equal to 1? No. Is n equal to 2? No. So nth Fibonacci 2 will be called. 3 minus 1 is 2. But what about this nth Fibonacci 1? 3 minus 2 is 1. This nth Fibonacci 1 is not yet called. So again the compiler will push it onto the stack that it has to be called. And this nth Fibonacci 2 will be invoked. Right? So 2 will be assigned to the parameter n. Is n equal to 1? No. Is n equal to 2? Yes. Return 1. So this 2 will return 1, this one, okay. Now return means go back to the main function. So this 1 will be taken back to the main function, but before that compiler will pop all the functions, whatever it is in the stack will call it, will be popped. So this nth Fibonacci 1 will be popped from the stack, right. This 1 is of nth Fibonacci 2. So this nth Fibonacci 1 will be invoked, n will become 1. If n equal to 1, it will return 0. So this nth Fibonacci 1 will return value 0. Nth Fibonacci 2 will be called and it will return 1. Can you see it? So 0 and 1. So these three values will be added. So 1 plus 0 plus 1 is 2. Now this nth Fibonacci 3 is left. So it will be invoked. So when nth Fibonacci 3 will be called and we'll get the value 3. Is 3 equal to 1? No. Is 3 equal to 2? No. Nth Fibonacci 3 minus 1, that is nth Fibonacci 2 will be called, and this nth Fibonacci 3 minus 2, that is 1, will be pushed to the stack. So nth Fibonacci 1 will be pushed to the stack and nth Fibonacci 2 will be invoked. So 2 will be assigned to parameter n and it will return value 1. 2 was already there. This will get you the value 1. 2 plus 1 is 3. And nth Fibonacci 1 will always return value 0. So 2 plus 1 is 3. That means the fifth Fibonacci value is 3. Let's run this program. Now running it is asking me to enter the nth Fibonacci number. I enter 5. The fifth Fibonacci number is 3. If I run it again, I want the 8th Fibonacci number. It is 13. So this program is running perfectly well.